Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And again, as always, take this easiness with a grain of salt because it's considered easy because by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Quattuor by Alaric Taki A, or otherwise known as Crusader 175. And here are the rules. We have normal Sudoku rules apply, which means in every cell in this grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have quadruples, where a digit shown in a circle must appear at least once in the 4 surrounding cells. So around this quad circle, there must be a 4. Around this quad circle, there must be a 5. Around this quad circle, there must be at least one 5. Around this quad circle, there must be at least one 3, etc., etc. And that's how quadruples work. We also have quad sums, where the 4 digits around a circle may repeat, and one digit must equal the sum of the other 3 digits. So, for example, you could have, say, a 1, 1, and 3 here, and therefore this could be 5. So this would add up fine, because 1, 1, and 3 add up to 5. And you just have to have 3 of the digits add up to basically the other digit that's around a quad circle. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so I've never done this quad sum rule, so I'm not sure. I don't have any intuitions right now about it. So the thing is, for any quad circle that's in a box, which means all 4 cells that it's surrounded are in a box, are in the same box, I should say, then they are never going to add up to anything less than 6, right? Because it's 1, 2, 3 at minimum. So therefore, anything with 4 in the box must add up to 7, 8, or 9. And anything with 5 in the box must add up to 8 or 9. Interesting. So we're guaranteed a 4 here. We are guaranteed a 5 here. This cannot be 4 or 5. If this is 4 or 5, if they say this was 4, that means 4 and 5 plus another digit must add up to another digit, right? Because none of them no 3 digits can ever add up to 5 or 4 by itself in the same box. So if you had 4 or 5 here, that would mean 4 or 5 would have to be there. Say we had 4 here. 5 would have to be around here. 4 plus 5 plus another digit would add to 10 at minimum, which is not possible. So this cannot be 4 or 5. So we have similarly 4 surrounding here and 5 surrounding here. It does change a little with 6. Oh, that's one thing, though. If you have... Right. If you have 2 sets of digits... So anytime you have 3 digits adding up to another single digit, as long as they're unique, you are guaranteed to have 2 digits from 1 through 3 having to be in that set of 3 digits adding up to the other digit. And the reason why is, like, take a look at all the possibilities. You have 1, 2, 3 adding up to 6. Sorry, you have to have at least 3 digits adding up to the other digit. So 1, 2, 3 adds up to 6. So that's 3 digits adding, which are from 1 through 3. 1, 2, 4 adds up to 7. You have 1 and 2, which are 2 digits from 1 through 3. To add up to 8, it's 1, 2, 5 or 1, 3, 4, both of which requiring 2 digits from 1 through 3. And 9 is 1, 2, 6, 1, 3, 5, or 2, 3, 4, adding up to 9, all of which require 2 unique digits adding up from 1 through 3 to add up to the fourth digit, right? So this is guaranteed to be 1 through 3. This is guaranteed to be 1 through 3 because this requires 2 digits from 1 through 3. This requires 2 digits from 1 through 3. And again, to add up to a single digit, that means there are guaranteed to have, if you don't have this one being 1 through 3, then you have to have 4 digits in that box required to be from 1 through 3, which is obviously not possible. So you have guaranteed 1 through 3 here, 1 through 3 here, 1 through 3 here because of that same thing. Even if this is 6, that's going to be the case. But we don't have anything else necessarily. This cannot be 1, 2, 3 adding up to 6 because if this is 1, 2, 3, again, we don't have we don't have two 1, 2, 3s available here to add up to the fourth digit, right? We need two 1, 2, 3s here. So this must be 1, 2, and 6 to add up to 9. Which means this can't add up to 9. It has to add up to 8 because we have 1 and 2 surrounding this 6. Because again, if we had 1, 2, 3 adding up to 6 here, the problem is these cannot be 1 through 3, and we need 2 1, 2, or 3s around this quad here to add up to a single digit for 3 unique digits. So this has to be 1, 2, and 6 adding up to 9. So we have 1, 2, 6, and 9 here. Obviously no 6 or 9 there. And if we have 2 here, that would be at minimum 3 and 4 adding up to 9. But we already have a 9 in the box accounted for. So then this has to be 1 with 3 and 4 adding up to 8. So this is 3 or 4 and 8. That means this can't be 1. This can't be 1. Obviously, that can't be 1. Remaining digits in this box are 5, 7 as a pair. So 1 cannot be here. We're then sharing either 2 or 3. If you're sharing 3, the problem with that is this would have to be 3, 4, and 1 or 3, 4, and 2. If we had sharing 3, this is 3, 5, and 1 adding up to 9. Well, this cannot add up to 9 because we already have a 9 accounted for in this box. So it would be adding up to 8 at most, which would require 3, 1, and 4 to add up to 8. So this can't be 3. This must be 2 then. So we're sharing 2. It cannot be 2, 2, and 5. It has to be 1, 2, and 5 adding up to 8. And this must be 2, 3, and 4 adding up to 9. So we have 3, 4, and 9. And this is 1, 5, and 8 here. This can't be 1 because of 1 in the column. That leaves 6, 7 remaining in the rest of the box. Okay. This is pretty interesting, actually, how these interact. So this has to be 1 or 3. You have the same problem if this is 3 here, right? This is 4 and 5. If you have 3, this is guaranteed to be 1, 3, 5 adding up to 9. This can no longer add up to 9. It would then have to be 1, 3, 4 adding up to 8, but we require 1 here if this is 3 again, and this was 3. So this cannot be 3 here. This is 1. So it cannot be 1, 2, and 5 here, adding up to 8, because that would force this to be 1, 3, 4 to add up to 8 also, which means that we duplicate 8 in the box. So this has to be 1, 3, 5, adding up to 9 here. So we have 3, 5, and 9 here. Therefore, this has to have 2 and 4 at minimum, because 4 and 6 add up to 10, which is too big. So 1, 2, and 4 add up to 7 here. This can't be 2 because of 2 in the row. That means the remaining digits in this box are 6 and 8. Okay. 1 can't be here, 1 can't be here. But 1 could be here. We know 2 and 4 in row 1 have to appear here. So this is 2 and 4. One eliminates 1 from being here, whereas the 1 in the box, it has to be here. Which means 1 has to be one of these 3. Where is 5? 5 has to be one of these 3 digits also. So this is 1 or 5. Where is 6? 6 cannot be. It's either one of these two or one of these two. Where is it in row 2 then? It has to be here. That's all we have really that information for. We are guaranteed a 3 here. So it could be 1, 2, 3, and 6 potentially. We are guaranteed a 3 here and a 3 here. That means 3 has to be here in row 4. Hmm. Hmm. One of these two must have a 4 surrounding it. So there must be a 4 here or a 4 here. If there's a 4 here, that means this can't be 4, so that's 4, which would force that to be 4. If there's a 4 here, that means this can't be 4, so 4 would have to be here, which means 4 couldn't be here. So we're guaranteed 4 has to be one of those two. We're guaranteed a 4 here, so that means 4 can never be anywhere else in columns 3 and 4. Right? Because we're guaranteed a 4 here, we're guaranteed a 4 here, so therefore there can't be 4 anymore. 1 has to be one of these 3 digits here. This could be 1, 1, and 2 adding up to 4. That is possible. This requires a 4. So it's either... So this requires a 4, which means 4 cannot be here. Where is the 4 surrounding this quad? It has to be here. So this is 4, which means this can't be 4 here. Which means this is a 3, 9 pair, so this is 4 here, which means this can't be 4 here. This is 2, 7 as a pair, which makes that a 4. This 2, 7 pair eliminates 2 and 7 here, and the rest of the rows, so this is 6, that's 7. 7 eliminates 7 here, so it's 5 and 7 there. 4 eliminates 4 from being here. This is 3, 9 as a pair, which eliminates 3, 9 in the rest of the column. So this is 2, 6 as a pair, which eliminates 2, 6 in the rest of the box. So that's 9. That leaves the remaining digits in column 3 as 1, 4, 8. And 4 cannot be here again. Okay. So we have 4 guaranteed here, 4 guaranteed here. 9 then has to be one of these 3. 7 has to be one of these 3. 2 has to be one of those 3. And we have 6 as one of those 3. Okay. So for 3, you could have 1, 3. So 1, 2, 3. 1, 3, 5. 1, 3, 4, and 1, 2, 3, 4 are the possibilities to add up to some other digit. This is 1, 2, 4. 1, 2, 1, 3, 4, or 2, 3, 4. This we're not certain of. Let's just do remaining digits now. In column 1, we have 2, 9, 3 or 5. In column 2, we have 6, 7, 3 or 5. We can't have 4 or 8. Yeah, that doesn't help much. We are guaranteed 3 here, and a guaranteed 3 here, which means 3 in the rest of column 4 has to be one of those 3. Remaining digits of row 3 can be 1, 5, 6 eliminates 6 here. So this is 8 and that's 6. Okay. We have 1, 5 here, and then the other possibility is 3 or 9. We have to have 6 and 7 here. So remaining digits of row 1 can be 2, has to be 2, 4. No 5. So 3, 8, or 9. Does that work? Probably. Remaining digits here cannot be 5 or 1. So it could be 3, 6, 7, 8, 9. That's pretty broad. Okay. So if where is the 6 in box 8? Can't be here. Can't be surrounding this because it's 4 with two other digits must add up to 7, 8, or 9. So 6 has to be one of these two, which means this can't be 6 here. Do we have any other information? Not particularly. So this cannot, okay, this is 6 here, and we know 3 cannot be surrounding it. So since 3 can't be surrounding it here, that means it cannot be 1, 2, 3 adding up to 6. It must be 1, 2, 6 adding up to 9. So therefore 1 is here, 1 is here. Where is 1 in box 5? It has to be one of these 2 digits, and this cannot be then 1, 3 with anything adding up to a single digit. It has to be 2, 3, and 4. So then this is 2, 3, 4, and 9. That means we're guaranteed this must contain a 2. We have 9 here and 9 here. That also contains a 2. We have a 2, 6, 9 triplet in row 5, which eliminates 2, 6, and 9 in the rest of the row. So no 2, 9 here. It's 3, 4, which eliminates 3, 4 in the rest of the box. This is 2, 9 as a pair, which eliminates 2, 9 in the rest of the box here. So this 1, 6 pair eliminates 1, 6 in the rest of the box. It's 2, 9 here, which eliminates 2, 9 in the rest of the row. So this is 6, and that's 2. Okay. Where is this one? The remaining digits in box 5 then are 1, 5, 6, 7, 8. No 7 here, no 7 here, no 7 here, no 6 here, no 6 here, no 6 here. No 1 here, no 1 here. No 5 here because of 5 in the row. This can't be 8 because of 8 in the column. No 1 here because of 1 in the column. We are guaranteed 3 and 9 in column 4 here. So this cannot be, well, yeah, it couldn't be 2, 3, 4 anyways. So to add up to a value, it has to be 1, 2, 4 here, adding up to 7, because we can't have 3 available here. So this is 1, 2, and 4, adding up to 7 here, which eliminates 1, 2, 4, and 7 in the rest of the box. So we have 3, 5, 6, 8, 9. And 6 again cannot be any of these 3. 9 has to be one of these 3, so this can't be 9 here. No 8 here because of 8 in the column. Remaining digits, this 3, 4 pair eliminates 3, 4 in the rest of the row, so this can't be 3, 4. It's 8, which makes this 3, which makes that 4. So 8 eliminates 8 here, so that's 5 and 8. So there's no 5 here, there's no 3 here. 8 eliminates 8 in the rest of the row, so this is 5, 7. Remaining digits in row 5 are 5 and 7. Remaining digits in row 6 are 7 and 8. Interesting. So can this ever add up to just 4 here? Okay, say this was 4. This has to have a 4. Say we try to have 4 and 8 here. 4 and 8 obviously don't add up to a single digit. So that means everything here must add up to 8, which would be 3 and 5 at minimum. So this cannot be 4, 8. It's 1, 4. This can't be 1. It's 8. That means there's no 8 here. This is 1 and 4, which adds up to 5. 5 plus 3 adds up to 8. 5 plus 5 adds up to 10. So that's not possible, so this must be a 3, 8 pair, which eliminates 3, 8 in the rest of the column. This can't be 3. This can't be 8. It's 7. This can't be 7. It's 5. No 3 or 5 here. It's 9. This can't be, this 7 eliminates 7 here, so it's 2 and 7. This 3, 8 pair eliminates, well, 8 here, and 5 eliminates 5 here, so that's 1, which makes this not 1. This can't be 1 or 5, so it's 6. This has to be 8 then. 1 and 7 eliminate 1 and 7 in the rest of the column, so this is 2, 4. 2, 4 as a pair eliminates 2, 4 in the rest of the box and column. So this can't be 4, it's 3. This can't be 3, it's 4. This can't be 2, it's 9. This can't be 9, it's 2. 3 and 9 eliminate 3 and 9 here, so it's 5, which means these can't be 5. Cannot be 5. That leaves this digit remaining as a 6, and this digit remaining as a 5. 5 eliminates 5 here, so it's 7. These can't be 7 then. 9 eliminates 9 here. So that's 2 or 3. We have to have a 3 surrounding this cell here. So this is 3. And we cannot have 2, 3, 6 adding up to a digit, or 2, 3, 7 adding up to a digit. So that means we are guaranteed a 1 here. 1, 2, and 3 add up to 6. So this is 6. That's 1. This is 7. 3 eliminates 3 here, so that's 2. 2 eliminates 2 here, so it's 4 and 2. Again, neither of these can be 2. 6 eliminates 6 here, so that's 1. No 3 either way here. Remain 5 eliminates 5 here, so it's 7, which makes that 8. Remaining digits in row 4 have to be 3, 4, and 5. Obviously, no 3 here. How does this work? 3 and 6 eliminate 3 and 6 in the rest of the column. No 3, 6. 7, 8 eliminates 7, 8 in the rest of the column. 1 eliminates 1 here. So can we not have a 1 here? Well, then the minimum of these digits would be 3, 4, and 5, which add up to 10. So the answer is no. So 1 has to be here, which means this can't be 1. Can we ever add up to 5? And the answer is no, right? Because you have to have 1, 1, and 3, or 1, 2, and 2 to add up to 5. So that means 1 and 5 plus another digit add up to a single digit. So it has to be 1, 3, and 5 adding up to 9. So this is 1, 3, 5 adding up to 9. So it's 5, that's 4. 9 eliminates 9 here, so it's 2 and 9. We don't have any more 9s in this box. 9 eliminates 9 here, so it's 3, which makes this 9, which makes that 3, which makes that 9. So no more 9 here, no more 3 here. This can't be 3, it's 6. No 3 or 6 here. These can't be 8 because of the 8 in the row. 4 eliminates 4 here, so that's 2. This can't be 2. This can't be 2. Okay. Okay, remaining digits in row 7 are 5, 6, and 7. This can't be 7, and 6, so this is 5, which makes this 6, which makes that 5. That leaves that as 7. 5 eliminates 5 here, so it's 3 and 5. 3 eliminates 3 here, so it's 4 and 3. 7 eliminates 7 here, so it's 8 and 7. We don't know about the 1s. We should have 8 2s, which we do. We know where the last 2 has to be. It has to be there. We don't have enough information about 3s. We have 8 4s. No, we don't. We don't have enough information about 4s. We have all 9 5s. 6s, we have 8 6s, so we know where the last 6 has to be. It has to be there. We have all 9 7s. 8, we don't have any information. 9. We know where 9 has to be in column 9, so that's 9, which means this can't be 9. That's 3, which makes that 9. 3 eliminates 3 here, so it's 8 and 3, which means 8 in column 7 cannot be here, so that's 8. And that leaves this as 1, which means this can't be 1. That's 4, which makes that 1, which makes this 4. And that's how you solve it. Pretty interesting how these interacted. I particularly like the break-in, actually, because that was very interesting about how I often use the there have to be two digits from 1 through 3 if you ever have 3 digits adding up to a single digit. So I'd use that fairly often, but I don't really see this way of sort of restricting it very often. So that was pretty cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.